In this video, section 1.6, simplifying exponents. Suppose we have an expression like this. We have x to the third power times x to the fourth power. We could rewrite this expression as, let's see here, 1, 2, 3 multiplications of x times 1, 2, 3, 4 multiplications of x. That's 1, 2, 3, 4, 5, 6, 7 multiplications of x altogether, x to the 7th power. 3 plus 4 is 7. So when we have a common base and we're multiplying, we add our exponents together. Let's take a look at a more complicated example. Let's take the expression 4 times x cubed times y to the 7th times x to the 9th times y to the minus 2. This 4 is the only constant, so it's going to just remain unchanged. Then we're going to take our x's and group them together. That's x cubed, x to the 9th. Likewise, we're going to take our y's and group them together. Y to the 7th times y to the minus 2. Now, we're going to go ahead and add these exponents. That's x to the 12th. We're going to add these exponents, y to the 5th. The fact that we have a negative value here doesn't change the fact that we're still adding. 7 plus a negative 2 is 5. Also, notice how the constant just remained constant. There was no other constant to multiply it with, so it just remained as is. And each one of these bits here in parentheses is similar to this little expression that we simplified to begin with. And that's the trick to simplifying exponents, is to just look for small little subproblems. And the same idea holds with division. You look for small little subproblems. So let's take the expression x cubed, y to the 5th, z to the 9th, divide it by z squared, y to the 4th, x to the 5th. And now what we're going to do is we're just going to break it up. We'll first take our x's and write them in their own parentheses. Then we'll take our y's, write them together. And finally, we'll take the z's and write them together. And then we simplify each one of these little subproblems. Now with division, we're going to subtract instead of add. So this will be x to the 3 minus 5, x to the negative 2, y to the 5 minus 4, y to the first power, z to the 9 minus 2, that's z to the 7th power. And if we wanted to, we could write this as y times z to the 7th divided by x squared. Remember, a negative exponent indicates a reciprocal. Okay. And similar to the last section, 1.5, we can also have distribution. So let's take the expression x squared, y cubed, raise it to the 5th power, and then multiply that by x cubed, y to the 4th. The first thing we're going to want to do is distribute this exponent. So we'll have x to the 10th, y to the 15th, and that's still times x cubed, y to the 4th. Now we're going to group our x's together. x to the 10th times x cubed, and group our y's together. Y to the 15th, y to the 4th. Now we'll just add these exponents, and we'll have x to the 13th times y to the 19th. So reviewing what we did here, we distributed, then we combined, we grouped, and then we combined. And the key to solving a problem like this is to work carefully and slowly. I've got one last example here, and it is a spicy one. This guy is going to be tricky, but if we work carefully and we just take it a step by time, we can solve. And we'll start by distributing. We'll have x to the 12th, y to the 4th, z to the minus 8. Next, we'll go ahead and we'll rewrite the rest of the numerator, x squared y. Now, we'll go ahead and we'll do the distribution in the denominator. We've got to be careful with this one because of the minus sign. So that's z to the minus 6, y to the positive 4. And finally, we'll distribute here. And each one of these three factors has that exponent applied to it. Okay, with that done, it's time to start grouping. We want to get all of our x's together. So that's x to the 12th, x squared, divided by x to the 5th. Now, we want to look at the y's. Y to the 4th times y, and that's going to be divided by y to the 4th, y to the 10th. Finally, we'll do the z's. Z to the minus 8 is our numerator, and we have z to the minus 6, z to the 5th in the denominator. Now we can go ahead and we can figure this out, but this is a lot going on here, so maybe we should do a little bit of scratch work. We're going to have 12 plus 2 minus 5. That's 14 minus 5, 9. This will be 4 plus 1 minus 4 plus 10. These cancel out. It's 11. And over here we have minus 8 minus a minus 6 minus 5. So this is minus 13 plus 6, or a negative 7. Okay, so this is x to the 9th, y to the 11th, z to the negative 7. All right. And that's it for section 1.6. Thanks.